So let's get started. Today, as you probably all know, is a review session. So before we get into it, I'm going to give a couple of notes before we get started. Make sure I'm sharing okay. So, number one, where should we start? Well, let's talk about the exam. So of course, the FAQ, the TOI, they're posted up there in their usual spots. I'm going to say about this. So first thing, historically, students have tended to do the best on this exam. Why? Maybe finally trying to study out of desperation and fear. Okay, that could be it. I don't know. It could be maybe the material or the exam are inherently easier. I don't know. Or it could be C, because stuff is finally starting to repeat and be understood, right? There's a lot of things in the YouTube module that are slight variations on things we've seen before. So I don't know, somewhere in between those three is probably why, but people do tend to do better on this exam. So what I'll say is don't panic. And what I see very often when students stop by to review their exams is they'll say, oh, I should have put that down. I erased the right answer and I put it, because they overthink. So don't panic and don't overthink the questions, right? So the exam is not, does not have trick questions, right? It is definitely detail oriented. Because why? Because IDS is detail oriented, right? If you write a big batch of code and there's one small error, the whole batch might fail, right? You guys at least intuitively understand this, that computer programming is a precise thing. This is why IDS is the way it is. It's more complex, maybe more detailed than other things. Like in finance, you have CAPM, you learn a little process how to do that calculations. In accounting, you have your double entry bookkeeping and you know how to do that. But IDS is kind of a whole different ballgame. So, but even though it's detail oriented, right, there are no trick questions. I am not trying to fool anyone. All right, so one student, there was a question on one of the exams about difference between clickbait and spam blogs, right? Clickbait is what it is. Spam blogs, though, spam blogs are just pages packed with ads and some jumbled mixes of words to try to, fool the search engines. And so if it's a spam blog, there's no real content there at all. So the question on one of the options on the question was difference between clickbait and spam blogs. It said clickbait often has interesting content, unlike spam blogs, right? And the student got all hung up on like what kind of precise percentage often meant. And I'm saying I'm not trying to do that. It's not like, the difference between, clickbait has 70% and that's not good enough to be considered often, right? I'm not trying to fool anybody like that. The point of that question was just spam blogs don't have interesting content. Clickbait, junky or not, at least you read it and there's something there. Okay? So stuff like that. The questions are what they seem to be. Don't overthink it. If you have a question about the exam or about a particular question or interpretation of the question, by all means, take a minute out of your exam time and come ask me, because, most of the students finish well ahead of time. There's time for that. Okay? There's that. Number 3, I don't know the curve in advance. I won't calculate it until the day I submit the course grades, which is the Wednesday after finals week. Okay, so there's really no point asking me before then, because I don't know, and I'm not going to know till Wednesday. And once I've submitted the grades, submitted the grades, they should become available fairly immediately after through the UIC portal, right? I don't post the course grades to Blackboard because why? Because number one, extra work, but also B, potential for mistakes, right? So it takes me about an hour to put in all these grades, and you know, with the sheer mass of grades I have to put in, it's inevitable that, you know, on occasion a wrong grade gets entered, and I don't want to do that on Blackboard, right? I catch almost all of them, but like every now and then, yeah, one does go through, which leads me to this. I also don't immediately reveal the grade cutoffs. And the reason for it is I have 500 students. With 500 students, inevitably, there's going to be a whole bunch of people that are pretty close to a cutoff and want to come around and grub for a few extra points, right? They're going to say, oh man, I was like 2 points away from a cutoff. And I'm, you know, it's not that I'm not sympathetic, but in a class this big, inevitably, there are going to be a bunch of people who are very close to any cutoff I might pick, right? And so the logic of, you know, I'm close, can you bump me up? Well, A, yes, I could, but B, no, I won't. Somebody's got to get the highest B, and that sucks. Somebody's got to get the highest C, and that sucks. I don't know what to tell you beyond that. Okay, so I don't immediately reveal the grade cutoffs, right, to prevent grubbing. And however, if, I was going to say like the Spice Girls, if you really got to know, really got to know, if you really need to know, right? Like, for example, suppose you say, well, suppose the actual cutoff for a C is 640 points, right? And suppose that you've done the math and you think that you have 641 and you have a buddy who you think has 640 points and you say, but you didn't get the C, you got a D. You might say, hey, you know, so-and-so got this and I got more than that and I should have at least the same grade as they do. It is possible that something has gone wrong. It's more likely, you know, for every inquiry I get where something is actually wrong with the grading, there's like 10 questions or 20 questions where it's like, oh no, you did the math wrong. So, you know, but mistakes happen. So if you really need to know afterward, absolutely, you are entirely welcome to stop by my office and ask, and I will tell you in January, okay? So look me up in January, that's fine. At that point, everybody's kind of settled down and had time to come to terms with whatever grades they've gotten. So there's that, okay? But if you really want to know afterward, yeah, I'll tell you. I should mention, nobody has ever actually stopped by a month later to ask about their grades, which suggests that, you know, the whole main point is grubbing, which leads back to that. Okay. What else? Oh, last thing. So, and this is, yeah, because I had 4 points in the morning and I have 5 points now, and this was the point I was trying to remember. Last point, number 5, course evaluations. You know, you should have already had now available. And if you have enjoyed this class, found something useful or interesting, whatever, by all means go in there and write a nice review of the course. If, on the other hand, the course has been, you know, an unrelenting nightmare and you're just glad to be done and you hope to never see me again, well, you know, that's fine too. And what I used to say for that was that, you know, if you have had a bad experience with this course, just remember that writing those course evaluations is not very fun and it's a lot of work, and you can probably think of something better to do for whatever. But last year I got promoted, and I am unlikely to, you know, as old as I am and close to retirement as I am pretty unlikely to chase the next tier of promotion. So whatever, you know, just, you know, write what you think, and that's great. Okay, so that's, I guess, about all I have. Oh, and I can't remember if I mentioned that I had misplaced my favorite coffee mug, but I found it, so I'm happy about that. So I know, I am pleased. Yeah, it was in the basement. Okay, so any questions about any of this course material stuff? Oh, look, people showed up. That's so nice. So if you haven't seen it already, you know, the FAQ and the TOI, they're in the usual place. Exam preparation, right? There's the TOI. Any of this stuff that anybody, yeah, go ahead, what? UIC portal. Yeah, because like I said, I don't post them to Blackboard, but it's been a long time since I was a student and had to look up where grades went, so you know more than I do. Yeah, no problem. I saw a hand up over here. Yeah. What's that? No, I can drink during the day without having to justify it with soccer. I mean, I wish the United States well, but no. Actually, I was one of those kids who was forced into playing soccer in the 70s and 80s, and I didn't really enjoy it. You know, it was okay to play, but, you know, the practice was blah. It was boring. Anyway, games were all right. So I don't have much enthusiasm for soccer. As punishment, we pushed our kids into it too. Although my daughter actually she's really good. She's fast. She's like a runner, you know, and she's she's big, and yeah, she just overpowers the other 7-year-old girls. But my son, yeah, he wasn't too thrilled about it. He just wanted to pull the net over himself. Anyway, yeah, yeah, okay. Oh, before I get into, okay, I got your thing. There is a last thing. Number 6, right? Again, people may already know this. The final exam is not cumulative except insofar as familiarity with prior topics is expected, right? But no detailed questions about Facebook or Amazon or Google, right? It's just that, for example, at this point, I should be able to mention in a question a relational database or a NoSQL database or a key value store, and you should know what I'm talking about without any additional explanation, okay? But I'm not going to ask you in detail for the properties of those. I'm just going to expect that you know what those things are. Okay, so you asked layers of TCP IP. Great. Okay. So TCP IP has 4 layers, okay? They are application, dun, 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 and there is transport, and there is internet, and there is link. Okay. And what these things do depends on whether it's an outgoing message, so I'm going to put this in red, outgoing. So the application layer basically takes application data and formats it to be sent over the internet. That's pretty much what that is. The transport layer, I always say, chops the app data into packets, right? Makes a packet sequence out of it. The internet layer figures out the destination address and, you know, basically puts it on each packet. I would say the destination address and I guess potentially the next stop, right? But that's fine. And the next router. So when you're sending a packet, for example, suppose you're sending a packet off of your computer, out of your home to someone else's home, what's going to happen is the machine is going to look at that packet and it's going to recognize, hey, this is an outgoing packet. Great. So probably the only machine yours is directly connected to is the router. So a packet goes to the router, which is, you know, network layer thing. The packet will be stamped with, oh, I know that this packet has to go to the router next. The router is going to look at it, it's going to pass it on to the next device. Okay, so that's basically what the internet layer does. The link layer, packet transmissions. Okay, so from your device to the next connected one. So if you're just directly connected to the router, what's going to happen is the link layer is going to schedule when that transmission is going to happen, and when it does, it's going to send that data as a bit stream to whatever network card you have, and it's going to transmit that to your router. Okay, that's the link layer stuff. Over here, we have on the incoming side, so there's going to be some device that receives this transmission, otherwise it wouldn't be a network. So we're going to go all the way down to the bottom first. So the link layer checks if the recipient is the intended next stop for the packet. Okay, so when a device receives a packet, there's a chance that the packet is not actually for that device at all. It makes a lot more sense if you think about wireless communication, right? So if I have my phone and I send out a message in packets, it could be heard by all of your devices as well, right? But if I'm only trying to send to somebody in that building over there, what'll happen is the link layer on my side will say, here's who the next recipient is. And then when your device receives it, you'll look at that and say, oh, I'm not the intended next recipient for this packet. I'm just going to ignore it. Okay? The internet layer on the receiving side checks if the recipient is the intended final stop for the packet. Okay, so the device, if the device is the next stop on the path, then the next thing to check is, okay, am I the final stop on this path, or do I have to send it off to another device? So for example, if you're sending a message from your home to somebody else on the other side of the world, at some point that device is going to have, that message is going to have to pass through the backbone. So it's going to be handed off to a bunch of different routers in that process. And most of those routers are not going to be, well, probably none of those routers are going to be the final recipient. It's just going to be when it gets to your friend's home network, that router is going to say, oh, not for me, I'm going to pass it on to this next device. Your friend's computer will look at that and say, oh, hey, link layer says I'm the intended next recipient, passes it up to the network layer. The network layer says, hey, I'm the final recipient for this. Great. When that happens, the transport layer says, converts, well, I'm going to say, assembles the incoming packet stream to a sequence of packets, right? That's what if the transport layer on outgoing took the application data, chopped it into a bunch of packets, well, when the transport layer gets a receiving message, it receives it as a packet, needs to assemble those packets back into a bunch of useful application data, okay? And the application data, of course, takes the packet sequence and processes it into application data, right? And unformats it as well, whatever. So if it's encrypted, it'll decrypt it. If it's compressed, it'll decompress it, stuff like that. Okay, is that good? That's good, okay. So yeah, the basic process, outgoing goes to these sequences, at some point will be received and go up through these sequences, these steps. Okay, TCP/IP. All right, what else? What else do we need to talk about? Anything? Huh. Yeah, sure. Okay. So remember, the point of Dash is to ensure that a video keeps playing despite variations in connection quality, okay? Because YouTube's overriding concern is to make sure the video doesn't grind to a halt, okay? People aren't happy when they're watching a video and it starts to stutter and stop, whatever. That's no fun. Most people would prefer a lower video quality over, you know, long and intermittent playback delays. Okay, so that's what YouTube is trying to do, is keep the video playing. Now, the way it does it, each packet, right, each video segment is delivered as the best quality that doesn't use up too much of the buffer, right? So remember, the buffer is the data that your browser has stored in advance before it starts to play it. So, for example, if your connection speed is great and you're watching, you know, some YouTube video that's high resolution and your connection speed has no problem keeping up with that, then even as YouTube is sending you data, the buffer is going to keep building up a little bit and everybody's happy, right? There's no problem. But suppose you're watching this high resolution video and at some point you walk into the next room and there's a big thick wall full of concrete and lead between you and the router, and suddenly your connection speed just crashes, right? So what's YouTube going to do? Well, YouTube wants to keep the video playing. So the first thing it's going to do, Dash will assess your current connection speed and the buffer reserves and deliver you a segment that, you know, basically, hopefully, doesn't use up too much buffer data. Now, the exact precise details of this are intentionally left out because there are a lot of judgment calls that this system has to make. So, for example, if you have a minute worth of buffer data and Dash calculates that, you know what, it's going to take about exactly a minute to deliver this next higher quality segment, you could argue that, okay, we have enough space in the buffer to deliver that, that's the one we should deliver. But it puts you in, you know, puts YouTube in kind of a risky situation, right? If the connection gets any worse, then it's going to take more than a minute, and the video, there's, you know, certainly some kind of safety margin built in there. We don't know exactly what it is. We're not really concerned about that. This is IDS 200, but basically, you know, at that point, if there's like a minute worth of buffer data, maybe at first YouTube would say, okay, we can deliver a segment that takes 30 seconds. That's probably going to be fine. And we'll see how things are 30 seconds from now. If the connection has gotten better, gotten worse, you know, we'll make that judgment call then. But basically, it's going to consider how much data it can deliver and what the current state of the buffer is, and make that decision about what's the best quality segment that it makes sense to send. Okay, now, suppose your connection speed improves after slowing down. At some point, right, so the first thing is, if Dash is sending you low quality segments, your buffer will start to rebuild again, right? Because these low quality segments don't require a lot of data. If your connection speed is getting better, that means, you know, your buffer is going to keep improving. You're going to have, you know, it's going to build up. At some point, Dash will decide to start sending you high quality segments again, right? Because your buffer is going to be built up to where your system can handle it. Your connection speed is good. It's fine. Okay? And that's what Dash does. That's what it does and why it does what it does. I believe this is getting recorded though. Let's see. I hope it is. Yeah, good. Okay. Other stuff? Oh, okay. It's available on Blackboard though. Yeah.
The OSI 7 layer network model.
Okay. All right. So OSI has 7 layers, right? It basically works the same way as the TCP/IP. It's just the application layer is broken up a little bit. So here's the OSI model. So those are the 7 layers, and we'll just do the outgoing because, you know, it works pretty much the same way as TCP/IP. So these 3 correspond to TCP/IP application layer. Okay, it's just broken down into more specific things. So the application layer sends out application data. Presentation layer is in charge of things like encryption and compression. And the session layer, one of the big things that does is synchronize related data streams. Again, in context of YouTube, if you're watching a video that has an audio stream associated with it, those 2 streams need to be synchronized so that, you know, the video plays correctly. Okay. Transport layer is pretty much the same, pretty much the TCP/IP transport layer, same thing, right? Likewise, the network layer, pretty much the TCP/IP internet layer, data link layer, you know, this is pretty much the TCP/IP link layer. And lastly, the physical layer, not included in the TCP/IP model, right? Reason is, if you think about what layers are and how they use standard interfaces, you don't actually need to specify a physical layer, because the data link layer, as long as it sends out the data to the physical layer in the appropriate format, you don't need to actually tell the physical layer anything other than that here's the format of the data you should accept. Okay, and this basically, I'm going to add here, this allows much greater hardware flexibility. Okay, you don't have to design one particular model of hardware that's compatible with this. You can have all kinds of different kinds of hardware. As long as they can process what the data link layer is sending them, or the link layer in TCP/IP, doesn't really matter the insides of this physical layer. Okay, so that's your TCP, and then, you know, again, works the same way going back. You know, the physical layer receives the packets, the data link layer checks, hey, is this packet for me? Am I the next stop? The network layer checks if you're the final destination. The transport layer assembles the packet stream into application data, which then gets, you know, unpacked and uncompressed and decrypted all the way to the application layer. But again, key point why we don't get into a lot of detail with this, nobody actually uses the OSI model because it lost the race to TCP/IP. All right, so there's, you know, not a good reason to go a whole lot of detail into this. It's a good thing because it's good for teaching. It really breaks down what all the different processes are. They have to happen in some kind of sequence, but yeah, that's about it. Okay, also I should mention one thing that's also, I guess I don't know if it's worth mentioning, but I'm going to parenthetically mention it. In industry, routers, which work on the network layer, are called layer 3 devices, and switches, which are the hardware that manage this data link stuff, are called layer 2 devices, right? which wouldn't make sense TCP/IP, right? If you're going that count with TCP/IP, link layer would be the first layer, network layer, internet layer would be the second one, all right? But because everybody in industry was kind of familiar with this, the terminology caught on to call switches layer 2 devices and call routers layer 3 devices. So for what that's worth, not going to be on the exam, but there is some slight relevance to the real world that OSI still has. Okay, other stuff? Yeah. Machine learning? Okay. Not a whole lot to say about that really, but what there is to say, I'll say. Okay. Machine learning basically takes a big pile of data and extracts some useful predictive rules for outcomes. Okay, so the example I gave in the slides is you might have a big, you have a big batch of video viewing data, and you want to find some rules. Right, so for example, maybe there is a 4-part video sequence where most people who watch the first 3 parts also watch the 4th part. And people who don't watch the first 3 parts are vanishingly unlikely to watch the 4th. Okay, then your simple rule is that you might come up with, if watch 1 plus 2 plus 3, expect watch 4, right? Which means that if you know about this, and this might be a very strong predictor, in which case you would say, oh, if I know about this person, that they've watched these 3 videos, or they've watched a group of videos whose viewing is correlated with 1, 2, 3, then yeah, maybe I either suggest video 4 as something they could watch, or I suggest video 1 that they could start on that train, something like that. Okay, that's basically what machine learning does. And if you become an IDS major, we have some 400 level course that you can take where you actually learn the math and the process behind that. But for this, you know, that's really just it. You have a big pile of data, you try to extract some useful rules. Okay, and it's similar to conventional data mining in that, you know, data mining will take a big batch of data and in a sense produce some rules, right? Like people who bought A, B, C often buy D, but it is a little different in how it gets implemented. So, and this is IDS 200, so I don't need to go too deep into this, but, you know, just don't come out of here telling people that, oh, Professor Doug said that machine learning is the same thing as data mining, because then some of the faculty, though, yeah. Yeah, that's one way of measuring the strength of a rule, if you want, right? So remember back when we were talking about data mining with correlations, and we had support and confidence and lift. This model, this is a lot like lift, right? So I'm going to say, guess I gotta close this out. Very similar to lift from data mining as far as assessing the strength of a rule, right? Basically, this rule has to be a better predictor than average in order for it to be useful. Like if everybody watches video 4, both the people who watch 1, 2, 3 and the people who don't watch any of them and the people who watch some but not all of them, then that rule has no substantial predictive value at all, and we don't care. But if it happens like this, that people who did watch those 3 watch 4, people who didn't watch those 3 don't watch 4, that's a pretty good rule. All right. So yeah, that's what machine learning is. Anyway, it's a neat topic. Yeah. But math and stuff, you know. Okay. Yeah. Yeah, there's not much to say about MySQL. I mean, it exists. Is it on the list there? I guess it is. Okay. Yeah, that's fine. MySQL is a relational database platform. That's it. I mean, that's what I gotta say. You can, you know, you can Google up MySQL. Okay. So that's got open source relational database management system. Ta-da. And you can use it. It's open source, so it's out there. Basically, YouTube could say, hey, this thing is open source, so it's free for us to borrow and implement and upgrade, which they did. Okay? Yeah. But that's what there is to say about that. I guess I'll add in open source. You guys go on to take, so I'll toss this out there because I don't know. Somebody asked this morning what other courses I teach. So of course I teach IDS 200, which is not really another course, it's this course. Then we have, and we know what this one is. Downstream of that one, I have IDS 201. It's not closely related, but it's Intro Java Programming. If you become an IDS major or you're thinking about it, I would say, hey, might as well learn how to use Java. It's still very useful in the real world. And if you do learn how to program Java, there's a pretty good chance that any other programming language you learn down the road will be substantially easier. So, you know, after Java, everything you're likely to do will be easier. So there's that. Downstream of 201, I also have IDS 313. Which is internet business applications. What that means in terms of coding, basically there's JavaScript, we do some more of that, we spend a few weeks on that. We do PHP, which is server-side scripting, and some network stuff, right? Network architecture, we talk about some of that. I would recommend that you take 201 before you take 313, even though it's not strictly required. Just that, again, if you've taken 201, the JavaScript and the PHP stuff will be really easy. If you haven't taken 201, I don't know. Maybe it'll still be easy, but probably not. I also teach intermittently, like usually in the summers, IDS 401, which is intermediate Java programming. So if you took 201 with me and you thought it was interesting, or fun, or otherwise useful, and you see that some summer I'm teaching 401, teaching it, then yeah, that's about it. And I have some graduate classes too, but it'll be a while before you're gonna take those, and they may not exist by that point anyway. Okay. Other stuff? Anything else? Yeah. Yeah. I used to code in applets. I took a course here. They still used them way back when. Applets are, well, first of all, let's get this out of the way. Nobody uses applets anymore. Okay? They are gone. But what they were, usually small Java applications that would run in some defined rectangular portion of a browser window or web page. Okay? That's what they were. So, you know, if you went to a page that had applets, what? Basically, first, your machine would check if it actually had Java installed, the Java virtual machine, which is necessary to run the programs, right? So needed to run the applet code. Second, your machine would download the applet code. And then finally, third, your machine would run the applet. And that's what would happen, okay? Reasons why applets went away. Applets were popular circa 1995 to 2005, somewhere in that window. They faded away because, number one, their graphics were pretty low end and thus not suitable for, you know, a lot of online games and stuff. And they had a public perception of being vulnerable to security threats. As it turned out, you know, Flash Player and the other plugins had more vulnerabilities, but, you know, at the time, those vulnerabilities hadn't really been too much explored by the bad guys. So that's pretty much it. That's what there is to say about applets. Yeah. Yeah, I think it was in 04, I took some enterprise network course where, yeah, we wrote applets and put them on a web page to, you know, pull database data. And about that same time, I remember reading an online article that said, why are people still teaching, you know, how to do these shitty applets in, you know, actual university courses? Nobody's going to be using them in a few years. Turned out to be right. Okay. Other stuff? All right, well, let's see. Do people know that I Scrabble? I play Scrabble? Have I mentioned that? I play Scrabble, not just, you know how to play, but I'm actually pretty good. So I played in a tournament over the weekend. I don't have much else to talk about at this point, but this was kind of neat. So I played in a tournament up in Elmhurst, and I got my new rating, 1900. I haven't played that much in the last few years because COVID and stuff. There hasn't been many tournaments around Chicago. But my new rating is 1900, which, if I go here and I look at the top players in North America, I'd be number 28. So that's kind of cool. I know Cecilia Lee, by the way. She's a nice lady. But, you know, she'd be number 29 if I were a little more active. Anyway, so that was fun. I've only mentioned it because I hit a century mark. I hit 1800 about 7 years ago, but you know, getting up better and better is work and takes a while. And yeah. So anyway, that was something. That was fun. Anyway, other stuff? We got anything? Sure. Okay. All right. So remember, latency is just how long the system takes to respond to, you know, your request. Basically how long it takes for you to get the response packets. Okay? And latency, you know, obviously it's going to happen the busier the system is, right? The systems only have so much capacity. So if there are many, many requests and the system can't service them all immediately, then things will slow down, right? And people will have to wait. That's latency, Okay, busy system means it's going to take longer for the system to respond to everybody's requests. Analogous to a traffic jam, right? If there are too many cars on the road only has so much capacity, you know, okay. Jitter is different. Jitter is variability of latency, meaning some packets arrive, fairly immediately, others much later. So I'm going to say, meaning for example, check that out, I guess. There we go. So that's the reason why I say, for example, right? If you're experiencing jitter in a system that already has fairly high latency, then it's going to be some packets arrive slow, others arrive much more slowly. So something like that too. So I'll mention this. You can see jitter in either TCP or UDP, right? But with TCP, packets will arrive in sequence, and the user may not experience jitter separately from latency for the whole message, if that makes sense, right? So imagine if you had a series of cars on the road and it's segmented out, but they're all connected. But for whatever reason, some of the cars take a long time to pass over one particular stretch of road, but they're still all arriving in sequence, right? So even if there are a bunch of cars that individually take a long time to get over that stretch, they're going to slow down all the other cars behind them. And what that means is at the end, it's going to feel like just latency, right? Because your application isn't going to be doing anything with those packets until they've all arrived and it can assemble them. So with TCP, because packets arrive in sequence, jitter, yeah, it's going to be a real thing at the network level if you like dig into it and see what's going on. But the user's probably just going to experience that as ordinary latency. But with UDP, packets may take separate different paths. And thus, if that happens, they may arrive out of order due to jitter, right? I mean, they could arrive out of order due to latency too, but jitter is going to make it more likely. If, for example, if the first batch of packets goes down a path that seems to be fast at that time, and then the second batch of packets go also down a path that seems to be fast at that time, but a different one, but then the first path gets slowed down, that second batch of packets might arrive before the whole first batch of packets does. Okay, this is not like a major thing, right? The key things you got to know are this, right? That's the big stuff. But if you understand all of this, then the questions that you might see on the exam are going to be pretty trivial in comparison. Okay, I'm just trying to bring in some more context, mention UDP, TCP, that sort of stuff. Okay. Other stuff, other questions? Going once? Going twice? Okay, gone. I declare this session complete. If you do have any, last minute questions, I guess you can email me. Although if everybody emails me, then there's going to be some latency on those responses. But I guess that's it. And we have the final whenever we have it. I mean, I know I have a bunch of finals, but I don't keep track too closely of when. I'll figure it out on Friday. There's our final exam. We are on, Friday, 8 a.m., right? So we're going to start at 9 a.m. Friday of finals week. Oh, there is a last thing. Another thing I got to mention in this, right? So again, hopefully the TAs will have everything graded by the end of the weekend, right? So I will push them to finish that so that if necessary, you can, correct any problems, right? Because remember, the deadline for submitting, for asking regrade or stuff like that is the Friday of finals week. So obviously you're going to need to have your stuff done in advance so you can look at it and see, yeah, does all this make sense? Okay? All right. Well, that's all I got then. I guess I'll see you probably next week. So enjoy the weekend. Good luck, all that stuff. All right. We'll see you.